Hello guys, welcome to my YouTube channel. Today I will be telling you how the train takes a turn on the curve, that is about the topic coning of wheel. So my name is Lavjeet Singh. Let us begin the topic. So I assume that the picture on the screen must be how you imagine the wheels of the train to be, but actually this is not the case. Before we go into that, let me explain you some of the parts of the wheelbase of the train. Okay, so here in the picture you are looking at a wheelbase of the train. This is the ground below. Okay, so this is the ground. On the ground there are two rails here. On the rails there are wheels of the train connected by an axle. All right, so this is how generally a wheelbase of the train looks like. Actually, this is how the wheelbase of the train looks like. The wheels of the train possess a slope on the edges, that is here, which is known as coning of the wheels. Now, in order to transfer the load from the wheels to the ground, the rails below the wheels are also kept at an angle with the ground. Now, this also helps the wheel to remain in touch with the rails while moving on the track. Now, this slope in the edges helps the train to take a turn on the curve. To understand it better, let us imagine the wheels of the train without the coning, that is, a slope in the edge. So, let us imagine a wheel without a slope in the edge. In this case, when the train takes a turn, the inner wheel, that is this one, and the outer wheel, that is this one, they both travel equal distances. Now, what will happen? Will the train be able to make a turn? The answer is actually no. Because to take a turn, we know that the inner wheel has to travel less distance than the outer wheel. So if we go mathematically, let the radius of the wheel be r, so the circumference is equals to 2 pi r. Now let L be the distance traveled by wheels of the train when the wheel completes one revolution. So you can say that L is equals to 2 pi r. Now both the wheels travel the same distance, which is equals to 2 pi r. Hence the train will not be able to take a turn. Now this here is the case of a wheel with a slope on its edges. So providing slope on the edges gives us a varying radius. You can see clearly here that wheel on the left has a radius small r on the left side and capital R on the right side. Similarly, the right wheel has a radius small r on the right side and capital R on the right side. Now, when the train takes a left turn, what happens is due to the centrifugal force, the whole wheelbase is shifted towards the right side. So when the train takes a left turn, due to the centrifugal force, the whole base here is shifted towards the right side. Now what happens is that the wheel on the left side here is moving with a radius small r, and the wheel on the right side here is moving with a radius capital R. So if you go mathematically, you can say that the distance traveled by the left wheel with a radius small r is equals to L1 and can be written as 2 pi small r. Similarly, for the right wheel, the distance traveled will be L2 and that is equals to 2 pi r with a capital R. Now here, since r is smaller than the capital R, you can say that L1 is less than L2. So the wheel on the left will travel less distance than the wheel on the right when it has to take a complete one rotation. So within one rotation, you can say that the wheel on the left will travel less distance than the wheel on the right. Now this makes it possible for the train to make a turn while moving on the curve. So this was all about today's topic, that is coning of wheels. I hope you liked it. If you do, please do like, share and subscribe to my YouTube channel. If you want me to make more videos on certain topics, please do leave your topic in the comment section below. Thank you very much.